How's that?
Tell me what I got.
Okay, we moved to a spot in the field about 2 rows from the area we made the direct application, and we picked the area where we saw as much symptomology as we did anywhere up and down the plot. The wind varies a bit when you apply these things. When you move 100 feet in the field making an application, you can't hold the wind speed constant. So we picked the area where we're seeing as much symptomology as we can. I think what we're looking at here, I would say, on the leaves is about a 25% leaf injury rating. And also, as I said, we were measuring height, and we'll measure yield a little later, but I would think that the height reduction here would be something in the 20% range as well. These beans are a little shorter than those if you look on down the row where there was no off-target movement. They're shortened up a bit.
That's good. Let's start over again. Tell me distance from treatment.
Okay. You ready?
Yep, go ahead.
Okay. We're in an area of the field where we're 2 rows over from the area where we made the direct application. These are 38-inch rows, a little wider than what they use in some area because this is furrow irrigated and they run the water down the row, so we're 76 inches at this point, if you like that terminology better. Okay. These are the leaf symptoms that I mentioned earlier that we call epinasty that we're assessing at this point in the field. That's about 76 inches from the area of application. And these symptoms that we look for are this abnormal leaf shape or leaf crinkling. Here's a leaf that's showing symptomology. And here's a new trifoliate that's coming out that's fairly normal that doesn't have it. So generally speaking, when I make an overall assessment at this point today, and these things are in flux based on how long ago the application was made and that kind of thing, I would call this in the neighborhood of 25% leaf injury. We've moved out to an area in the field that's 5 38-inch rows from the area where we made the direct application, and in this spot we wanted to have an example here of about where the damage changed from what we thought was about 25% leaf injury to an area that might be what we think is about 20% leaf injury. Certainly we're measuring this closely at different stages, and I'm not trying to preempt any of the data that'll come off of this plot, but I'm just telling you it's a subjective measurement, and that's how I would call it at this plot here today. We have again some of the leaves still showing a little bit of the epinasty that we spoke of, and there's one that shows a good bit of it, but a good bit of the foliage is normal in it. So as time goes by, a lot of these plants tend to recover, and the symptomology is always there, but when it becomes a less percentage of the total foliage of the plant, it makes it more difficult to call it the same percentage. You know, it's relative to how much foliage there is in the total plant in my mind. So this one would be, I would say, I would rate this around 20% on leaf injury, and we're getting to the point where I would call height reduction somewhere in the 10 to 12% range, I think. We've moved to a point in the field where we feel like the leaf injury is at about 15%. We're moving out at 5% increments, and this area is 8 rows from the area where we made the direct application. And you can see that the symptoms on the leaves that have symptoms are slighter than those that were near the plot, and we think I would judge them today at about 15%. And also, most of the leaves in the top of the plant have recovered and are showing no leaf symptomology, so it covers up a little bit some of those leaves that may be showing a little bit of the symptomology that I'm looking at. When we start talking about height here, with this 15%, what I'm calling 15% leaf injury, I would say that there is no height reduction. The plant seems to have recovered its apical dominance and is growing straight up. there is a little bit, and I don't know if you can capture it in this, but if there is some lateral growth that's retarded a little bit. So if I look down the row, I can see this 15% injury in that it makes the plant, all of these branches on the outside may not hardly be growing out into the row as much as they would if they'd not come in contact with the herbicide. After you have a little bit of experience looking at this kind of thing, that's one thing that comes to mind as you judge this. But you know, I think we're definitely getting to the point when we get out here with the combine, I suspect there'll be very little effect on yield in this plot at this rate, at this 8 rows over. In this experiment with these nozzles, you know, it looks like to me these beans are going to yield well here. As you can see, they're well potted up from top to bottom. We've moved out to a spot that's 12 rows from the area of direct application, and we're moving pretty much perpendicular to the area of application, and we have come to a spot that I feel like the leaf injury symptoms are at about 10%. And the way I come to that conclusion is that I can see these symptoms on these plants without reaching down and moving the vegetation out of the way to pick up the symptoms. If I could point in this area, I can see without moving the plants that there's some light symptoms on the leaves. So this is about what I would call 10% leaf injury symptom. I can see very little effect on the height, either from how tall the beans are or how they've grown laterally at this level of leaf injury. If it goes to something I call 5% leaf injury at this growth stage, you know, I'll be digging around in the canopy to find leaf symptoms, and that's how I kind of judge the change from something that we started at from 25, 15, 10 to where they're clearly visible. I mean 10 to where they're visible without moving the canopy, and we'll look at 5 here in just a second where you have to search for them. We're at an area in the field where we selected what we thought were 10% leaf injury symptoms, and as it turns out, in this plot with these nozzles, we're 10 rows out. 10 rows, 10%. That's not always true, but in this experiment, that's kind of how it looks here today.
Go ahead and tell me the injury again.
Okay, the 10% injury is an injury symptom that I can see it without physically moving the vegetation. If I could point to some of the leaves, you can see that there's light symptomology on that leaf when you compare it to a leaf that has no symptomology like that leaf. We'll move out to the point where we expect to see about 5% leaf injury symptom, and when we get to that point, we'll move the vegetation and search to find these similar injury symptoms somewhere down in the canopy.
And tell me about it.
We're at a point here now, 13 rows, pretty much from the center of the plot where we were using a TTI nozzle here at Keiser. That's the nozzle that makes the coarsest droplets that we have. We feel like it does about as good a job as we can do with off-target movement. We're down to the point where we have something that I would call 5% injury, and the way I rate 5% injury at this point is that I have to reach into the canopy and start to look for leaves that have been affected. And you can see that if you look in the right place, there are some leaves that still show some small visible injury symptoms, but it's the kind of thing that you just don't walk right up to and see them everywhere. You have to know what it is you're looking for, and hopefully you can see these injury symptoms that I'm talking about. And most of this foliage up on the top of the plants have recovered and covered up that kind of injury. So we're getting down to where there is no lateral or apical difference or height difference. As I said there, the plant has recovered apically and it's growing up, and there's no lateral effect from the herbicide movement out of the plot here, and certainly we would expect no significant yield injury at this point.
About the 13th row.
16th row,
16th.
I believe.
Yeah.
I believe we're now at the 16th row from the area where we made the direct application of our package mix product of glyphosate and dicamba in these conventional soybeans, which are extremely susceptible to the product, but we're trying to assess what damage might be done. And we're at a point in this plot, in this test, that I just can't find any injury symptoms at all. We're at about the nearest point to the plot that we sprayed here that I would call zero injury. So I'm not saying that's the way it's going to be in every plot. I've seen wind conditions that we've sprayed in and weather and environmental conditions where the product moved further than this, but this is kind of an example of the injury ratings that we're using out here and how we're trying to understand the movement of the product around the area of application. So hopefully by the time we come to the field in Arkansas with this product, we'll understand the product in Arkansas, within Arkansas environmental conditions, and that's always important, and we hope to be able to put these together with our academic cooperators all around the Mid-South and develop a set of recommendations that will perform in our area and allow farmers to use this technology, which is proven to be really effective against Palmer amaranth, the weed that we're struggling with so much in all our crops here in the Mid-South.